Good evening, everyone. The session tonight is entitled Teaching with the New ACI 31814 Building Code, and it's a session for primarily for educators, but hopefully others interest as well. It's being put on by the Hot Topics Committee of ACI. My name is Randy Poston. I'm the past chair of 318, so I'm very happy with that new title. And tonight I'm going to just give you a very short presentation to start off with, and then we're going to have 6 presentations by very distinguished educators on their view of the world in teaching with the new building code. So, as you know, it's now available both in hard copy and PDF format. The mobile formats will be available very shortly within the next week or so. Just a little bit, give you a little bit of flavor and history of where we've been in a time. In 2003, when Jim White was chair, the Committee 318 began discussion about some sort of either simplification or reorganization. We called it a lot of different things and explored a number of different ideas. In 2006, ACI did a survey going back and looking at sent it out to about 4,000 individuals that had purchased the 2005 building code, asked them, or previous codes, and asked them about their feeling about their experience with 318. Got some good feedback from that. After that, 2006, we had a focus group with 2 different focus groups with structural engineers, one in Chicago and one in Seattle, asking both from a construction point of view, designers and other professionals, building officials, what their view of 318 was and what could we do to help in restructuring or reorganizing the building code. We took that information and had a workshop in 2007 in Chicago that concluded that the reorganization effort should continue. In 2007, a steering committee or a task group within 318 looked at what might be done, and we developed an outline based on the information we had gotten from the various surveys, focus groups, and talking to professionals and industry people about what might be done with 318. And with that as the starting position, in spring of 2008 at the Los Angeles meeting, Committee 318 started on the reorganization of the code. The survey, we found out a number of things from the survey, but it was clear that engineers were saying that they wanted all the information that related to a member design and detailing easily located, and they wanted the code to be very closely related to the design process. So something more evolving to how you do a design, the code following in a pattern such as the design process. As you know, from 71 forward through the 2011 code, the central chapters were 7 to 12. We have in their analysis, serviceability, strength, flexure, shear, and related reinforcement details. The specialty chapters, as might be referred to, we had separate chapters on two-way slabs and on footing, so we had some structural member design chapters, but then we had different chapters related to various construction techniques, all of them related to certainly for cast-in-place concrete, but we had separate chapters on precast, on pre-stress, and a separate chapter on seismic. So we really had, up through 2011, kind of a blend of ideas where we're looking at types of construction systems, behavior, and member types. So the major goal, a couple of major goals in reorganizing 318 was to develop an organization that followed the design process. We wanted to be able to have the user find the information quickly. And the other thing is we heard that designers particularly wanted to increase the certainty that a design fully met the code. So how do we do that, particularly when you have provisions that are spread out throughout the code? So the heart of the 31814 organization is really what we say is we're terming loosely a member-based code. It's the member chapters are in order and have a very similar design feel to them. We have one-way slabs, two-way slabs, beams, columns, walls. A new chapter on diaphragms, foundations, plain concrete members. So that is really the heart of this new 31814 organization. And one of the things that ACI staff has prepared are transition keys. So if you have your provisions that particularly in notes and whatever that you designed by, there are transition keys that will take you from 318.14 back to where you can find those provisions in 318.11 and vice versa. 318.11 will tell you where they're at in 318.14. So those are free for downloading on the website, and certainly would recommend that you take a look at those. And that will be helpful as you, particularly in class notes and whatever, where you had a provision, you reference a provision, and you want to now find it in the new code. That will be an easy place to locate it and find it. So tonight we're going to have presentations from Charlie Dolan, University of Wyoming, Robert Frosch from Purdue University, Jack Maley, University of California at Berkeley, Gustavo Para-Montesinos at University of Wisconsin-Madison, Jim White, University of Michigan, and then Khaled Lawi from the American Concrete Institute, who will be specifically talking about the design manual that ACI has already prepared following the 31814 format. So with that, Charlie, I'm going to ask you to go ahead and come up and get this started.
Thank you, Randy. The topic that we had was talking to educators. The title I put up is Teaching to the ACI 31814. I don't teach to the code. I don't suspect many of you teach to the code. You don't teach the code. We'll go through that, but I couldn't get a longer conjunction in there and still get the title to work properly. As Randy just said, the previous codes were behavior-based. This in many ways was really good for teaching, because if the students don't understand the behavior, the rest of it doesn't work. The 2014 code is member-based, and as I have up here, behavior-based assumes you know something about putting a building together. Behavior-based means you understand something about behavior. In short, if I look at what does the student need to know, I assume the faculty already know it. The student needs to understand the behavior, because if they don't, then they can't make the transition into what the code says. The students also need to know how a structure is developed. And so my first concern is that the code doesn't allow a good transition to either of these. You have to somehow get the two integrated. So somewhere about 5 years ago, when we had an inkling of what the code might look like, I began changing the way I taught concrete at Wyoming. And to understand that, you have to understand our program, because as many of you will know, you'll have civil and environmental, civil and architectural, civil and street sweeping, whatever goes along with, like highways where every piece of trash is used to fill in the concrete. We have a civil and architectural engineering program. So we're spending probably half of our student body is architectural engineers. That makes for some interesting variations in how the courses are taught. For example, our Structures 1 course has approximately a third of the course teaching ASCE 7. So our students supposedly know loads from day one, and it's a prerequisite for the concrete design. That means we never get time to do statically indeterminate structures, which if you teach concrete, you need to know something about. And it's all because the architectural engineers begin their architectural studios in the junior year. That's about the same time concrete comes along. So we've got a little bit of a hiccup that's different than some programs. So what I do is I teach structural concrete on two parallel tracks. One track is the behavior track: bending, shear, bond and development, columns. This would be what I would call a classical program. The other thing I do is a building systems project inside the class, and this I put into 3 student teams. My experience has been 3 students, I'm pretty sure all 3 are working. 4 students, I know 1 isn't. 2 students, it's too much work. So 3 works out about right. To make it work, what I do is I put together a project that requires the students to develop the building loads first, then the member loads, and then to do the member design. And I do it this way because they can be doing the loads while I get far enough along with flexure to the flexure part of the lectures that they can actually do something in concrete. And those of you that teach a course know that you've got to get in 2 or 3 weeks before you can begin to do reasonable homework problems, and the students have enough background. So, as Randy pointed out, the material in the toolboxes, the back chapters, are where you're going to find bending, shear, axial load, the fundamental behavior parts of the code. These are now in Chapter 22. I actually teach reinforcement before I get to serviceability, so bond, development length, cutoffs and stuff are in Chapter 25. Chapter 24 is serviceability. So we're working through this in the project that I do, then serviceability checks come dead last in the process. The next thing I need to do is look at a project. And so for this part of it, I take a building, in this particular case, it happens to be a hospital down near Loveland, Colorado, that I watch go up. We talk about what a building looks like at the end, and fortunately, I was there at the beginning, so we have a series of pictures of the construction of the building. And so the students learn, slabs, beams, what do these different members do, and a little bit how do they go together. So that's kind of the beginning. I then start dumping this design project on it. So all of the students, they don't like this one because it's a lot of work. Students, not to worry, it's a lot of work for the faculty to grade it too. So we'll go through that. But in this case, what I look at is I first ask the students to get the loads on the members that are in color up there. So I've got a red one-way slab, a couple of beams, and I've got some columns. After they do all the loads, I recalibrate and I give them the answers, because I have approximately 250% variation in the moments at the end of a beam. And I'd like to get them back on the same floor. Part of the calibration is they have to go through and they have to estimate sizes. So they have to get slab sizes, beam sizes, and all of that. So that accounts for some of the variation. Then they do the one-way slab, and I have them use the ACI moment coefficients. A, they haven't had indeterminate structures, and B, I want them to know that the loads add up to at least WL squared over 8. And that's a great surprise to some of them. The one-way slab, next I do the beams. And I do a couple of typical beams. I take an interior one because it has the 2 end moments, and then I'll take another one up in the corner that frames into a column, because I'm eventually going to have them look at a column. The column itself, I typically take a corner column, and again with a one-way slab, I've got one-way bending on the column, and they've got to work through where some loads on a column come from, and so then I have a column that has axial load and moment on it, and we'll look at the column 2 or 3 floors down because the top one isn't as much fun. And I have them do a beam column connection, so they have to figure out how to get the steel into the column, how to bend it because the column isn't big enough. And they work through all of this. And depending on where I am in the semester, I have them do a simple spread footing so that now they've seen the entire building. From the overall picture, I've had no good deed goes unpunished. I have about half of A through K to report on complex projects, theory to practice, all of this stuff. But that project gets you into being able to address a number of the ABET requirements. The member chapter in the new code is going to be a real godsend to this. Since I didn't have the member chapters when I was doing this, everything kind of got put together. With the new code, the students are going to be able to take each one of these pieces that they have to do, go to the code, go from A to Z, check off each step, and make sure they have all the parts done. So I see this as a major benefit of incorporating the code into the class. Grading a project, if you're a faculty member and you're saying, how do I grade 40, 50 individual designs. What I ended up doing was a peer review within class. They pass in all their reports on each submittal. I pass them back to a different group. I give them a checklist and say, grade it for me. And I will post on the board or give a handout of approximately where the answers should be. And so I expect them to come back and learn. One of the things that happens is by the last submittal in this class, they're starting to look pretty good. They've learned what real garbage looks like from courtesy of their colleagues, which, again, the faculty know, but the students don't always see it. And in my own case, I have a MathCAD program that I just change a few parameters each time and gives me the full set of solutions. So, with that, and trying to keep the time down, this is just like that first picture you saw of the skeleton of the building. We have a cover for the book. The contents of the book are being worked on as we speak, but it should be available soon in 2015. I'm hoping the others are going to have their books up. And with that, Randy?
Okay, Charlie? All right. Next up is Robert Frosch.
Thanks. Thanks, Randy. I wanted to talk a little bit about the integration of particular the code into the classroom and how to basically affect your notes or the way that you would maybe want to go through the outline of 318.14 and accommodate it. I'm not looking at saying that you want to change your notes to fit 318.14. I think we all have our way of teaching a reinforced concrete class. So I think it's how do you navigate the code to integrate into what you are doing in the code. So I'm going to show you what I consider the typical undergrad class. At Purdue, the students that take concrete, so kind of give a little bit of background there, is generally they are going to be in construction or structures. So we have it as a specialty. So across civil, you do not just take this class. It's only if you specialize in structures or construction, and every once in a while we'll get someone else. So we wouldn't have a student in environmental engineering, for instance, in this class. But it's kind of a more traditional, it looks a little bit similar to what Charlie was showing, that we would have flexure starting out within the class. And then I actually get into serviceability and in particular crack control deflections. And so handle really the beam type elements first and then start getting into shear. And then moving further into the class, now getting the detailing, in particular development of the reinforcement, how do you lay that out in the member. And then I actually do a project that's based into one-way systems. So similar to Charlie, designing a floor of a structure. So not the columns, but the gravity load system of an entire floor. And so that's where they start to see continuity of systems and bringing all of the pieces above into their semester. So at Purdue, not only do we have the lecture, we also have a lab that goes along with the class, and it's a 3-hour lab that occurs once a week. So that's where we can get into more of the design and detailing of the structure. And then finally, at the end of the semester, we really have about a week or 2 weeks to cover columns, and we only do non-slender columns in that portion. So slender columns are held for a graduate level course. So going back into this, one of the first things that you introduce to the student is the materials. And you say, hey, here's the concrete and here's the steel. So in the new code, we have these chapters that start at 19 when we pass the members. And the first one is it's concrete. And so the title's a little longer, but it's focused on concrete, in particular the properties of concrete. So I find that this code lays out very well into the way that you would teach the class, that you can get into here and start to tell them about F prime C. The properties are defined. What's the E? What's the modulus for rupture? And if you're talking about lightweight concrete, there's your lambda. So it gives them that knowledge about the material and how do we specify the concrete. Chapter 20 follows up directly with steel. And so this is where you have your FY, E of steel. If you had pre-stress and you're teaching a pre-stress class, it has your properties for the E of pre-stressing steel and some other material properties for the steel. So I think those two chapters are very good that go along with the material section of your course. And then I'm starting to really get into flexure now. And so as I start talking about flexure, or these material behaviors, that's where these toolboxes, and I think you really, before just jumping into one of the member-based chapters, that toolbox and understanding that structure is very important to teaching the students how those toolboxes work and the behavior. And so as was shown already, we have chapter 21 through 25, which are kind of the meat of these toolboxes. And we have the strength reduction factors, sectional strength, chapter 22. And I just highlighted so we didn't leave it out here, but strut and tie modeling, that would not be covered in, obviously, the introductory course. But getting into serviceability, that's one of the major topics. And then the reinforcement details. So it follows very well along the typical topics that we would cover in an undergraduate course. So I wanted to get into just a couple of the chapters. So as I'm looking now in particular at teaching this behavior aspect and flexure and shear, this chapter 22 on sectional strength is just perfect because I have design assumptions. And in there, we're covering about the design assumptions for moment and axial. And so that's where we're talking about 003 strain and what are our assumptions that we use for design, which follows with 22.3 flexural strength. And when I finally hit the columns, it has a section on axial strength or combining, where I'm doing my interaction diagram. And so again, understanding how to navigate this toolbox, I think, is fundamental. And then if you're doing shear, which is the one-way shear, which is going to be covered in the course, there's the section. So you go right into that, and you get, now they understand how to get their capacities, nominal, and then applying chapter 21 right before their phi factors. The member chapters are great, as Charlie was mentioning, because now within one chapter, everything that they have flows together. So whether I'm doing a one-way slab, a beam, or a column. So those are the chapters that will be used throughout this course. In particular, when I'm getting the design project, similar to what I think Charlie was indicating. So when I'm bringing in the continuity and how to put this whole project together, you can step through the one-way slab design, and all of the pieces from start to end are going to be there. For beams, the same situation. So the member chapters really guide the way for the students of how to design that member. And I want to show a little bit of the details in that common outline. So in all of the member chapters, they follow this outline. We start with the scope of the chapter and some general thoughts about the member. But then we get into design limits. So, for instance, how thick can the member as a minimum could be if I neglect deflections? Any of these type of limits. And then the required strength. What are the moments that I have to design for? MU, which is going to refer them to the appropriate parts of the code. The design strength, the phi MN, directing them now to the toolbox. So they understand now the interplay. So once they understand that toolbox, you can really navigate through these member chapters. And then the reinforcement limits. So minimum amount of flexural steel, minimum amount of shear steel, and then finally the detailing that's required for that member. So really an integral part of trying to do a project where you're designing the entire member. And so a couple other things I wanted to mention is, especially as you're starting to do these type projects, and again, when you're giving them just calculation type problems of doing a member and trying to calculate the forces on it, is there's chapter 5, which is the loads, and that gives you your load factor and combination. So that's the major section that you would be referencing. And then the structural analysis. And I wanted to bring two sections that would be the real piece that you would use inside of your typical undergrad course. In simplified methods, that's where we have these moment coefficients that Charlie was mentioning. And I strongly believe whenever I teach that course that they need to understand those coefficients, because they will go through and run finite element analysis programs, get all type of forces out of it. They have no clue if those forces are right or not. I make them check it with these simplified methods to understand the ballpark, and they should have a feeling of what those answers should be before they even run the structural analysis. So I use those, and so I'm very glad we retained that in the 14 code, that we didn't just say, well, we can just do structural analysis with a computer. I think they're very valuable tools, and I stress that in the class. And then there is the first analysis procedure. Obviously, I'm not going to get into second order analysis in this introductory course. So that is very compact in that section of 6.5 and 6.6. So finally, kind of to get to the whole piece now, after they understand the strength, and much like Charlie, I later on kind of read into the serviceability of deflections and the crack control. Those are contained in a couple of sections now. And then the shrinkage and temperature reinforcement you'd utilize. So I just wanted to mention one word on a graduate course, since we're talking about just generally teaching. Once they have that basic outline and understanding how the toolbox chapters integrate with the member chapters, a graduate course, and this is an example of the topics that I cover in the advanced concrete course: slender columns, torsion, two-way slabs, beam column joints, and strut and tie modeling. Each of those follow exactly that. We have a chapter within Chapter 6. That's where the slender column analysis procedures are outlined. It's in the analysis chapter. Torsion has a section just for that. Two-way slabs, we have a whole chapter that outlines that. It has the equivalent frame method, direct design method. We have a chapter that's specifically about beam column, slab column joints, and I cover that in the course. And then strut and tie modeling. The entire chapter, which was formerly an appendix, is now there. So I think that one is very simple to integrate once you understand that other piece of how the toolboxes integrate that you would gain out of your undergrad course. So I think we're going to have questions after. So
Thank you, Robert. Next up is Jack Maley.
All right. So, I teach things a little differently on the West Coast because we deal with the earthquake problem. And so what I want to talk about is sort of how the code fits in with what we do on the West Coast. And it's different. And there is this book, but it talks about things seismic. And that's how we teach most of the classes on the West Coast, is really with a focus on earthquake engineering and what's required to understand earthquake engineering. And I've been surprised to hear the previous two speakers mention that the new code is a member-based code. I thought it was a systems-based code, in the sense that there's, in Chapter 4, is a systems chapter. And the systems chapter talks about how a building as a whole is supposed to be put together and how all of the forces are to be resisted and what kinds of elements come into this. And I think it's really important that this new code takes the time out to actually explain that what you're designing is not beams, columns, slabs, and so forth. You're designing a structural system that's going to hang together under whatever the loads are that get thrown at it. And the West Coast, we're mainly worried about the earthquake loading, and so we're worried about seismic framing systems and diaphragms and things like that. The things that strike me about the new code are things like the fact that there's a diaphragm chapter. For the first time, we have a chapter on diaphragms that's applicable to all sorts of buildings. We've always had diaphragms in the seismic chapter, which used to be 21 and now it's 18. But now we talk about diaphragms in general, because diaphragms are not just a thing for earthquake resistance. The diaphragm's what keeps your building together. It makes sure that your frames and your walls, which are sort of typically planar, actually stay in their plane. Okay, that's what the diaphragm does. And so the fact that the new code talks about this for the first time is really important. And the fact that it talks about the system and what the requirements are is really important. And that should be part of what's taught, I think, in every class, undergraduate to graduate. And we do this on the West Coast because if we don't have a diaphragm for building resisting earthquakes, we're in big trouble. The new code also has, in its seismic chapter, it's updated some of its provisions, very importantly. And so the new code is not just organized in a new way, it has some new things that are really, really important. And I'm so happy that when I teach the Reinforced Concrete Seismic Design class at Berkeley, I don't have to make excuses anymore about the column confinement provisions. I'm so happy that the column confinement provisions actually recognize that the amount of confinement should vary with the amount of axial force. And it's great that it does that. And there's lots of other important technical changes that have gone into this code. It's not just all reorganization. And the new code makes much better use of tables and equations and figures than the past codes have done. And so one of these figures, actually, I think the upper one, is in the commentary to help engineers figure out how they're supposed to place reinforcement in a special structural wall. So it's not just a bunch of words, but actually some diagrams that help you figure out how to do it. And in foundations, we worry a lot about foundations out west because the loadings are so different. And it's great to see that the strut and tie method has been elevated to its own chapter. It's in the code now instead of in an appendix. And one of the things that we didn't get really time to do in the last code cycle was to update a lot of the foundation provision. But one of the things we're aiming for the next code cycle is really to get these things updated. And to see how things really come together is great. And so I love seeing pictures of real buildings coming together and what gravity framing looks like. And when we teach a reinforced concrete class at Berkeley, we talk about how the gravity frame works. It's not just the shear walls and the frames and the foundations and the diaphragms, but all the other stuff that goes with it. And I think it's great that this code is organized to bring all those things together. Thanks.
Thank you, Jack. Next up is Gustavo Paramontesinos from University of Wisconsin-Madison.
Thank you, Randy. I'm not going to give you too much detail about the new code. I think I will try to focus a little bit more on what I think are important things students should know before starting to use the code, so that they understand how to apply actually the provisions. And in particular, when we are not dealing with seismic, the technical changes in terms of member designs actually are very few for this code. So one of the things that as I've been working on this textbook, that is to how are students, new students or practicing engineers going to use this code, and basically because of the whole structure has changed. And one of the things is that, they have to become very, very familiar with the code structure. And not only in terms of the overall structure of the code, in terms of member chapters and toolbox chapters and things like that, but also how the structures or the structure of each chapter is for the member design chapters or the toolbox chapters. And also how is the reference system used in the code from one chapter to the next. Randy and others have talked about the distribution of topics throughout the code, so I'm not going to spend much time going through this, but the one thing I will point out is the member design chapters, chapters 7 through 13. We have connections, and then some of the toolbox chapters, things that apply to different types of members, strength reduction factors, strength of sections, and concrete and steel requirements. Now, within each chapter, though, at least the ones that refer to the design of members, there is a common theme or a common sequence of provisions, and starts typically with the scope, the application of the provisions of that particular chapter, some general requirements, and then design limits, strength requirements, require strength and design strength, and then it goes to the limits, reinforcement limits, and reinforcement detailing. Now, I think it is key to understand that how each chapter really works, and one big thing in this code is that all design requirements for a given type of member are present in that member. The requirements themselves may not be explicitly mentioned there, but the need to satisfy a certain provision is there in all the design chapters. So the main concern that we had in previous codes, that people were not quite sure that they were done with the design of a member because different provisions were in different chapters for the same type of member, well, that's gone. So that is something that it is very important. Now, the other thing is, well, what should we expect to have in a design chapter in terms of the explicit provision versus a toolbox chapter? So we have to understand that when you have provisions that apply to more than one type of member, to different types of members, then we shouldn't expect that provision to be in the chapter itself. There will be a provision that tells you you have to satisfy this, but the actual requirement or the detail of the requirement will be in a toolbox chapter. So, for example, when we talk about a concrete cover, well, we're not going to have general concrete cover provisions in each member chapter. Now, there will be actually in each chapter referring to a chapter on that has the provisions for concrete cover. Or, for example, Robert talked about the toolbox chapter on strength. So we have sectional strength and axial strength, shear strength, flexure, and torsion. Well, the requirements to satisfy those strength requirements or calculate the strength in a certain way are in each member chapter, but the design equations are actually in the toolbox chapter. So we have in many cases, actually, the same provision applies to two different chapters, but in one we have the detailed provision and the other one just the need to satisfy that provision. However, when we have a particular requirement or requirement that applies to a particular type of member, or maybe two types of members, not to all members in general, then those provisions are expected to be, or you should expect to see them in the chapter themselves, because they cannot be in the toolbox chapter since they are not general provisions that apply to many types of members. So, for example, when you have termination of reinforcing, flexural reinforcement in beams, well, that is actually in the beams chapter. Same thing for minimum flexural and shear reinforcement in beams and other flexural members. So when there are particular provisions, you should expect those there. Now, from a designer's perspective, I would say that the single most important improvement in the code is the fact that you can feel confident that once you go through the entire member design chapter, for whatever type of member you are dealing with, you are going to be done with the design of the member. So that is something that I think was one of the biggest concerns prior to this edition of the code, and I think that was one of the main drivers behind the decision of reorganizing the code. Now, from a teaching or a teacher's perspective, or in this case also from a textbook writer's viewpoint, one of the things I've encountered quite a few times is the fact that when you're dealing, for example, with beams or columns, is, you know, how do you refer to the requirement? You may have a certain requirement that is actually in the toolbox chapter, but then the way you would, the requirement to be satisfied in columns is in the columns chapter, but then there's a reference to a toolbox chapter. So I just put one example here, chapter 7. For slabs, and we have a provision that has to do with deflections, but it says, well, you need to satisfy or calculate deflections in accordance with something in chapter 24, and you have to satisfy limits also in another section of chapter 24. So one thing that is important is, you know, if you have a textbook, make sure that students know from the beginning what is the structure of the code and this reference system, because you may actually be tempted to go straight and say, well, slabs should satisfy these limits, and go straight to chapter 24, bypassing the requirement in chapter 7 that basically sends you to the other chapter. So there is a little bit of a repetition, and I think that's probably one of the challenges that or the most common challenge I've found as we work with the design chapters is how to deal with this double sort of set of provisions. In one, again, is a detailed provision, the other one is just a reference to the detailed provision. So with this, I will conclude, and I guess we'll deal with questions later. Thank you.
Thank you, Gustavo. So next up is Professor Jim White, University of Michigan.
Thank you, Randy, and thanks to all the others for giving all the descriptions of what's in the code and all of that stuff. I guess my presentation is going to be a bit more laid back. I wasn't exactly sure what to tell you about teaching reinforced concrete design that you don't already know. And again, I think a lot of people have tried to say that there have not been that many technical changes in the code, except, as Jack said, I think there's been some nice changes in the seismic part. And so some people have asked me about my book. Oh, you're going to have to completely rewrite your book or something, and I don't think so, because I think I'm going to teach pretty much the same way that I have continued to teach. Now, some of you in the room might be kind of feeling like this. My class is starting in 2 months, shortly after January 1st, and I just today got a copy of the new code. What should I do? Well, I've actually been teaching a graduate course this fall, and the code hasn't been available yet, and I'd just like to tell you to relax. My thought is flexural theory has not changed. Shear analysis and the design procedure for shear has not changed. If you're going to do straight or hooked bar anchorage, those links have not changed. So I don't think you need to make a wholesale revision of how you're going to teach a reinforced concrete design course. You will need to kind of get straightened out as to where have these things gone. And again, you more than likely, when you're teaching flexure or shear, you might tie that into a beam design. You might tie it into a one-way slab design. When you're hooking bars, you might tie that into either one of those members. So I'm not sure that there's going to need to be any sort of a wholesale change in how you teach these things. One of the things, and Randy, you brought this up, and Khalid, you might talk more about it, something that's been very beneficial to me over the last summer as I've been trying to update my book. One of the most difficult things, and Gustavo was getting at that, is to get all of the code references correct because they are all different. And this transition key that the ACI engineering staff put together, this was available right around, I believe, the 1st of May, about the same time the code went out for public comments. And this is an extremely valuable resource to those of you who might be updating your existing notes or something like that. And again, I believe, as Randy said, we have here a couple of columns where something was in 318.11 and where it now appears in 318.14. There also is a listing of notes, but Khalid, I didn't notice many notes there, so anyway, you're kind of on your own. But this I found extremely useful and also extremely accurate. I only found a few things that I didn't think were correct, and I tried to let the engineering staff know about that. But this is something, for instance, that I'm doing in my notes this fall when the students don't yet have a copy of the 318.14 code. This, you know, it's kind of irrelevant what I'm going through. I'm doing some sort of an iterative design of a flanged section in flexure, and as part of it, it's in a positive bending region. Part of that iteration, I need to calculate the value for A there, which would be the depth of Whitney's stress block, and so I need to know something about the effective width of the compression flange. And that used to be located in Chapter 8. It's now found in 6.3.2.1. And so the notes that I'm distributing to my students, this is the way they look. I've just gone through and edited them without necessarily correcting them completely yet. Maybe in another year I'll have to just forget about referring to 8.12.3, but do something like that. And also I think, you know, this is a graduate class, so we are into two-way slabs, and we might be calculating deflections and having deflection limits, which used to be in Chapter 9, but now those are given in Chapter 8, which is for two-way slabs. But the interior of the table has not changed. So like I said, a lot of the technical details about how you design and detail reinforced concrete has not changed, just things have been relocated. So anyway, this is something I might suggest to you if you're starting to teach your course in 2 months and you don't have time to rewrite all of your notes or get everything. Do a little work with that transition key, and I think you can kind of get things straightened out a bit. You do run into a little bit of a situation here where you might have one thing listed in the 318-11, 765, and then suddenly you've got 4 references in 318.14. Well, remember, we have member chapters, and I think as Gustavo was pointing out, you have some of the same things you do for every member. This is actually something related to minimum or maximum spacing, I think, on flexural reinforcement used in slabs and walls. It was nicely contained in one section. Now it appears, but again, it appears in Chapter 7 for one-way slabs. It appears in Chapter 8 for two-way slabs, and it appears in Chapter 11 for walls. So again, it's just been kind of relocated. And so in my graduate class, I teach a bit about structural walls. And so if I come across this provision, I'll be referring to Chapter 11. I won't be giving them the reference for one-way slabs or two-way slabs if I'm talking about walls. So I would just give them the references in Chapter 11, for instance. So you have some of that. Then you have a few of them that are really difficult. This is kind of a general section, but again, 7 is one-way slabs, 8 is two-way slabs, 9 is beams, 10 is columns, 11 is walls, 16 are connections, and 22 is part of the toolbox chapter. So anyway, you'll run into a few of these things, but what topic are you dealing with? Are you dealing with columns? Well, then you go to the column chapter. If you're dealing with beams, you go to the beam chapter reference. So again, Matt, I see you out there. Thank you very much, Matt. I think this has been a very valuable resource to me as I've tried to put together an update of my textbook. So, as I said, relax. There will be an adjustment period that you need to go through as an instructor. You're going to need to learn where everything is in the code. And you're going to need to, and I think many people have said, the students are going to have to understand how the code is laid out. But every time they come into the first course in reinforced concrete design, they've never seen the code before. So you need to teach that anyway. Use the resources that are provided by ACI. Now, I've just talked about one resource here in my presentation. I think, Colin, you're maybe going to talk about some other resources that may be available. And then also, I don't know exactly, but new editions of the textbook, I'm assuming, are going to be out and available by next fall. And Jack, I guess yours is already available, and I couldn't tell quite, Charlie, if yours is available January 1st or May 1st, I don't know. My book personally, I've done most of the legwork on it, but it's in a review stage, and it's not going to be out until maybe May or something like that, so it won't be available for anybody teaching during the winter or spring semester, as you may call it. In Michigan, we call it the winter semester, not the spring semester, because we're truthful, truth in advertising. So anyway, that's it for me. I'd be happy to try and answer any questions or interact with any of the other speakers. Thank you.
Thank you, Jim. Next up is Khalid Nawali from ACI staff, and he's going to be particularly focused on the ACI Concrete Design Manual update and how it integrates in with the ACI 318-14.
Good evening. I'm not an educator, so I will be talking about the Reinforced Concrete Design Manual from a different perspective from what you've heard before. By the end of this presentation, you'll agree with me that this manual is a good tool or a good resource for professionals and a great companion to ACI 318-14. This manual is directed towards professionals who are infrequent users of ACI 318 and are interested in the design and construction of reinforced concrete buildings. It's also intended towards students who have completed structural analysis and design of strength of materials. The worked examples may be a good resource for a design concrete class, and but the discussions the discussions assume that the user has a working knowledge of reinforced concrete design. Organization, the way this manual is organized is following ACI 318-14. So, and here you'll see the content. Here are the topics. They are mainly all the member chapters, and here's the ACI 318-14 chapter numbers, and here's the manual chapters. So we're following more or less the same organization of the code. The first 3 chapters follow the code, and they are not example-based, but provide context of these items as they are related to reinforced concrete structures. They are sort of a refresher general, concise information that is located in one place and can be read in one sitting. Structural systems. ACI 318 added a new chapter that provides minimum requirements for for reinforced concrete buildings. It is sort of a roadmap to the rest of the code. It provides minimum requirements for design and detailing of reinforced concrete. A structural engineer main responsibility is to design safe structures and to ensure that the system, the supporting system, can support the gravity and lateral loads. Excuse me here. So the manual chapter provides sort of an overall the chapter on structural systems in the manual provides an overall review of the main structural systems in current building practice. There's also quite a bit of discussion on floor assemblies, one- and two-way slabs. There's a foundation, strength, serviceability, durability, integrity, QA and QC that will help the engineer when they're going through their project. Analysis. Elastic analysis is required to determine the design forces and deformations in your members. And the structural engineer responsibility is to design safe structures and make sure that the design strength of a member or the strength of a member exceeds the factored design loads. First order linear elastic analysis is the most common discussed, has been the most common discussed method of analysis over the history of the code. In ACI 318 has placed or has been placing simplified methods to aid the engineer or the designer in designing his structures by using hand calculations. And so, but today's powerful computers have made those simplified analysis methods sort of not necessary, but they still remain in the code, as I mentioned, to help the designer in his to design structures, simplified structures by, like in this case here, using the portal method. So overall, the chapter in this manual provides an overall review of the different analysis methods that are out there. Here's a table from the manual where we have the different member chapters that use the calculation, the hand calculations, and where they are located within the code or the manual. Here's also the different other analysis methods that use computer programs. I will not go into those details. The structural system analysis, the structural systems chapter references materials chapters 18 and 19 quite frequently. And they are used as, because of this, the material chapters are considered toolbox chapters. Before starting an analysis, the engineer must choose the concrete and reinforcement properties. Those are usually given in the code, but concrete durability may be a little bit difficult for, may not be familiar, or an engineer may not be familiar with. So this manual, we added a durability chapter that explains exposures that may be used in a building structure, so that where we have here the freeze-thaw, the sulfate attack, water permeability, and corrosion. So this is a chapter that may help the engineer in deciding what exposure to use and how to use them, especially in a building that is in service, and to determine the surrounding environment. For this, we used a 7-story fictitious building that has columns, walls, shear walls, 1 two-way slabs, beams, girders, transfer girders. So each one of those, and we used examples examples from this building in each one of those member chapters. As you also see here, we have a retaining wall chapter, although it's not a member-based, it's not a member in the code, but we added this retaining wall chapter. We've also, as I mentioned, at least one member is included in one of those member chapters, but we also have other examples to explain the different code requirements. The way an example is presented, we have a small discussion text that provides key notes or key points to refresh the user's knowledge as far as what the main key points are in that chapter. The example has a problem statement, a solution, details, conclusions. The way the problem is presented, where it's in a 3-column format. The first column shows the code provisions. The second column has the discussion. And the third, where we have the calculations. Next step, we have the detailing of a member. We show the detailing of a member. And in some cases, or where it's relevant, we have conclusion at the end of the problem to point out main issues or main items to discuss that are related to the problem or to other problems that are similar. Like in this case here, we have anchorage problems. Sometimes here, this durability deflection chapter is more of a tool design aid chapter. In some cases, you have to design or refine your calculations when it comes to deflection for a T section. So we have figures, tables for I cracked and M crack moment. Appendixes for volume 1, we have tables for bar properties. We have also show, for example, a maximum number of bars that can be placed in a beam. Also development length of bars and standard hooks and tension tables. There are also analysis tables, section properties, and column interaction diagrams. Those used to be within the manual. They were taken out and put in the appendix. Volume 2 is the anchoring to concrete. The reason that is a separate volume because there are about 19 examples, so it's quite lengthy, and it's divided into single anchors and group of anchors. The single anchors, they have those 3 topics. It's like tension only, shear only, and combined tension and shear. And each one of those examples, has about 3 to 4 examples for that type of anchor. For example, tension has cast-in anchor, has also post-installed mechanical and post-installed adhesive. And in a few of those, we have also examples with hooked anchors. For a group of anchors, we have here the concentric tension force, the shear force and moment, tension force with double eccentricity, and 4 pier bolts subjected to tension and shear. Also here, the appendix, there are useful tables for headed anchors, material properties, dimension properties, and bearing area of headed studs, and so forth. Here, available tensile and shear effective strength of threaded anchors. Also, we have sample data for torque-controlled expansion anchor and post-installed adhesive anchors. Those have data that are fictitious, but as an engineer, you need to go and get those data from the manufacturer. So here we provide all those, although they are realistic, but again, an engineer should go to the manufacturer to get those data. But it's just a sample to show what data are available or what data needs to be obtained in order to design your anchor with this. Thank you.